रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली अऊज़ु बिल्लाहि मिनश शैतानिर रजीम बिस्मिल्लाहिर रहमानिर रहीम सुब्हानल्लाहि वल्हम्दुलिल्लाहि वला इलाहा इल्लल्लाह वल्लाहु अकबर वला हौला वला कुव्वता इल्ला बिल्लाहिल अलिय्यिल अज़ीम अल्लाहुम्मा सल्लि अला मुहम्मदिन व अला आलि मुहम्मद कमा सल्लैता अला इब्राहीम व अला आलि इब्राहीम इन्नका हमीदुम मजीद. Okay guys, in this video I will find the tension in an inextensible string rotating a ball of mass m in a horizontal circle for the first time in world history. In this example I will use the two parts of the Tahirian monad as below. mv square cos square beta over r minus md square r over dt square. Okay, so you can see the monad on top of the screen, tt if-1, Tahir triad of inertial force 1. So this is a centrifugal force mv square cos square beta over r minus md square r over dt square. It's a centrifugal force. It will, when it breaks under physical conditions of a third force, tension here, in addition to inertia and gravitation as below, it breaks up into two components, mv square over r, beta is equal to 0, mdv over dt, beta is equal to pi by 2. Because third force has been added, so it will, the astronomical stuff will break up into physics. Okay, so the diagram is here. For the figure, force is acting on an extensible string rotating a ball of mass m in horizontal circle. We'll do the case first for theta less than 90 degree, where v square over r less than g. Okay, I will solve the steady state condition first, where d theta over dt is equal to 0. When d theta over dt is constant, it's not changing first, and then I will solve the non-steady state for the ball going up scenario, where d theta over dt is not equal to 0. The second term in the Tahirian centrifugal force is d square r over dt square and is equal to 0 because the string is assumed in as extensible. It's not extending. What is happening here is that two mechanical forces or their rectangular components are tension and gravity are competing with the forces of Tahir, inertial forces. X direction is the direction of the line of action of tension and the y direction is perpendicular to it, and the z direction is out of the paper or into the paper or out of the screen or into the screen. Okay, so from the above figure, the previous figure, summation of forces in the x direction gives Tahir summation of x is equal to 0, t minus mv square over mg cos beta. It's very simple guys. Summation of in the x direction in the line of action of the tension gives this one. Okay, the T is the tension, mv square over r is at beta is equal to 0, the centrifugal part of the centrifugal force, and mg cos theta is the component of gravity. Similarly, summation of forces in the y direction gives Tahir another equation as below. This is important guys. Okay, so summation of forces in the y direction mv square over r minus mg sin theta is equal to 0. Guys, mv square over r is the phase shifted force. It is not the mv square over r above. It's a mv square over r out of the plane, phase shifted, minus mg sin theta is equal to 0. mg sin theta is the component of gravity counteracting with the inertial force, the phase shifted inertial force. You can add I here, I mv square over r, or you can skip I. Why? Because there is no other component. Let's say the other component is 0. So 0 plus I mv square over r. If you take the magnitude, you get the same thing, mv square over r. So you can consider mv square over r minus. In my next non-steady case, I will consider I mv square over r. I will show you how the magnitude comes out to be the same, mv square over r. Okay, so t minus mv square over r is equal to mg cos theta, and the other one mv square over r is equal to mg sin theta. So t is mv square over r plus mg cos theta. You put the value of cos theta, mg cos theta, you get these three equations. Very simple. For g greater than v square over r or v square over r less than g. Okay, for v square over r less than g, we need to, okay, so this is the tension for v square over r greater than equal to g, greater than g. This is the tension. For v square over r greater than g or g is less than v square over r, we need to proceed cautiously as below because the angle theta becomes 90 degree. Now a phase shift happens in the direction of the tension force only, thus producing a phase shifted rectangular component, a phasor in the downward direction to count. Why? Because if you keep on rotating with higher velocity, it will it the mv square over r, the phase shifted force will become higher, greater, and it will start lifting the disturbing the balance in the vertical direction. So there must be something added in mg to counteract it. So what is that? It is the phase shifted component, the one in here, t is equal to mv square over r plus square root of m square g square minus this one, v4 over r4. So you will see how when we take the square root of -1 out, when r square over v square over r becomes greater than g, we take it out. So we introduce the phase shifted component. Using plus sign, the system of the force of tension becomes a phasor and no longer a real number. It now has, but it has got both the real parts. The force is real. The shifted force, phase shifted force is real. It just become an what you call a complex number. It now has a phase shifted part as well. Okay, so the tension phasor becomes mv square over r plus I mv square over r beta. Guys, mv square over r beta is the phase shifted part which has been shifted at 90 degree to the tension, which is now mv square over r only. So that will support mg. So that will be added in mg to support mg, to counteract mv square r over r, the extra upward force. Okay, so beta is the 1 minus g square r square over v4. Beta is greater than or equal to 0, less than 1. So t is mv square over r. We can also write the above as below in the complex number notation. So t is mv square over 1 plus beta square e to the power iota phi, where phi is equal to tan inverse beta is called the Tahir phase shift in the tension's direction only, and is represented by the mighty Iranian Sir Abul Wafa al-Buzjani's tangent function. Abul Wafa al-Buzjani was the guy who introduced tangent function for the first time in Islamic history. The mighty was born in 328 AH in Buzjan, modern day Iran. The magnitude of the tension force is T is equal to mv square over 1 plus square root of 1 plus beta square. Khazini. 1 Khazini is the force which, when acted upon an object of mass 1 kilogram, produces an acceleration of 1 meter per second. The above representation is not that intuitive, guys, though mathematically elegant, because it contains exponential and might be confusing for beginners in Tahirian cosmology. The best way to understand the phase shift is to consider the phase shifted part of the rotated value containing I, leaving the unrotated part in the original direction of tension. The vector never rotates, but only the phase shifted part of it undergoes rotation. However, even after rotation, it still retains its phase shifted nature, meaning I associated with it. The vector never rotates, but only the phase shifted part of it undergoes rotation. However, even after rotation, it still retains its phase shifted nature. It does not behave like an ordinary component with other vectors already acting in line of action of rotation. Amazing, isn't it? Al-Khazini, Abul Fatah al-Khazini, who flourished in the 6th century AH, was the only Muslim founding father of mass, force and weight, concepts that were later confused by Newton and ignored by Einstein till the advent of Dr. Tahir. He proved that heaviness, weight, was not an intrinsic property but a force that changed based on the distance from the center of the earth, the inverse linear law of Islamic gravitation. So force is directly proportional to 1 over r was given by Al-Khazini. Similarly, force is directly proportional to 1 over r square, 1 over r3 and 1 over, which served as the foundation for Newton to start with. It was not Newton who discovered F should be 1 over r square. It was Al-Khazini who started it with the linear law. He was the first Muslim in the history of humans to propose that the gravitational force varies according to distance from the center of the earth. A starter in the Islamic field of gravitation. Gravitation is an Islamic field. In the history of science, the founding foundations of modern astronomy were laid by the people of the West, the Muslims, the Westerners, Al-Maghrabis, and not by the aliens, non-Muslims. So e to the power I5 is the unit vector in Tahirian cosmology, where beta is equal to the square root of blah blah blah. The forces balance in both directions in the critical regime of v square over r greater than or equal to g should follow the following condition: mv square over r t cos theta phi. Guys, again confusing but elegant. No phase vector actually basically does not rotate, only its phase shifted part rotate. Its other part, the non-phase shifted part, remains in the direction of tension, or T is equal to mv square. The other part, mv square over r beta, that rotates in the direction of mg to support it against the top force, mv square over r. Okay, so no phase shift in horizontal direction. mv square over r is equal to it sine phi plus mg. Guys, again non-intuitive, confusing, highly intuitive but confusing. Phase shifted in the vertical direction only. Or mv square over r is equal to t. Okay, so since it's a phase shifted force, it's not a regular force that will be just added in the direction of mg. So it's a phase shifted force. So it will be added in the complex manner, like the magnitude of a complex number. So phase shift in the vertical direction. Okay, so beta is equal to 1g. Okay, so mv square over blah blah blah, mv square. Okay, that's how the phasor system keeps balance. So guys, this is very important. Look, that's how the phasor system keeps balance in the vertical direction. So when you insert the value of beta, the mg will automatically cancel, and the vertical mv square over r will be equal to the mv square over r, the downward force, which is t sine phi whole square plus mg. Mg is acting downward. So the phasors, that's how the phasor system keeps balance. Look, it sine y, Tahir phase shift. The tension is not rotated. Only the phase shifted part of it is rotated in the direction of mg to support the upward mv square over r. Because if you keep rotating it with higher velocity, the mv square r will become greater, and the ball was supposed to go up. The ball won't go up because the phasor keeps its own balance in the vertical direction. Amazing, huh? For theta is equal to 90 degree, v square over r greater than g. Forces acting on an inextensible string rotating a ball of mass in a horizontal circle for theta is equal to 90 degree, v square over r is equal to g. Okay, guys, now let me find the maximum tension in the string as follows for the steady state case. So T is equal to mv square over r plus square root of blah 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 dt over dv is equal to 0, and we get v square over r is equal to g over 2. Differentiation is left as an exercise for you guys. Substituting the above value back in the Tahirian equation below, I have mv square over r blah blah blah. So we see that theta comes out to be 45 degree. For maximum tension in steady state only when d theta over dt is equal to 0. The ball is neither going up nor coming down. The tension is given as below. So the value of the tension is given as below. T max is equal to 2 square root of 2 mg, where g is greater than or equal to v square over r, or v square over r is less than or equal to g. We also see that the minimum tension occurs at theta is equal to 90 degree and theta is equal to 90 degree and 0 degree. So T minimum is equal to mg for theta v square over r at 90 degree. The above analysis was with the condition that d theta over dt is equal to 0, or steady state analysis. Now I will do the analysis of the scenario above with d theta over dt greater than or equal to 0, or non-steady state, or the ball going up. To do that, I will break the motion into two parts, guys. One part is the motion of the mass that I have already discussed above along a horizontal plane, and the other part is the motion of the same mass along the vertical plane, that it goes up instantaneously. This has not been done to make life easier, guys, but it can be done because differential instant nature perfectly approves it as a correct course of action. However, it may still look easier at the same time. So T is in x direction, V prime is in y direction, V double prime is in the z direction. Okay. TCR is the Tahir center of rotation. So V2 is in the going into the plane of the paper or screen, and V prime is the motion is into the Z direction. I mean into the plane of the paper. So V prime is perpendicular to the plane containing V prime and TCR. I mean tight center of tension. And V2 prime is the force in the plane containing V prime and V2 prime. V prime and V2 prime. Both planes intersect at the mass. Forces acting on an extensible string rotating a ball of mass m in a curve spiraling upward. 0 theta less than 90 degree and v square r less than g. Let v prime be the speed of the mass and it goes up in the vertical plane instantaneously. Let the corresponding angle be represented as above by theta. I have v prime is equal to r d theta over dt. Very simple, guys. V prime is in the plane containing v prime and the string, and v double prime is in the plane containing v prime and v2 prime. Both planes are orthogonal to each other. Okay, let v2 prime be the speed of the mass as it goes around in the horizontal plane instantaneously into the paper, into the plane of the paper. Into the paper or into the screen. Let the corresponding angle be represented by what do you call it, phi. I have v double prime is equal to r d phi over dt, sigma or phi, whatever. Z is the direction into and out of the paper or screen. We also have v square is equal to v prime square plus v double prime square. Now all three velocities are in the plane perpendicular to the plane generated by the string as it spirals up. Okay, the plane of the cone, the spiraling cone. V is the resultant or actual speed of the mass tangential to the spiral curve that it follows while going up. That's the resultant. Okay, so now summation of forces in the Z direction. Z direction is out of the paper or screen of the V double prime. Okay, guys, the phase shifted I am V prime square over R is equal to M dV2 over dt. Guys, this is the state of the art. This is a physical force. This is not imaginary. This is not a hallucinated force. Okay, so now this force does not have any other force in its direction before. So its magnitude will be found by considering any real portion as 0. So 0 square plus m prime square r whole square is equal to. So you see how we get the same force, because there is already no force acting in that direction, and it acts as a couple. It acts in both directions, but one part of the couple is taken by m dv double prime over dt as counteractive force to it. So they will come in counteraction, like mechanical forces counteract inertial counteract mechanical. But in this case, two inertial forces lock up each other and they counteract each other. Tahirian cosmology, state of the art. Okay, guys, similarly, summation in the y direction is equal to 0. Phase shifted I m v double prime square over r, mg sine theta plus m dv prime over dt. Okay, so we will take its magnitude. Why? Because it's a phase shifted force. You cannot just, if there is already any component in that direction, you cannot just add it simply. You have, because it's a phase shifted, it got I with it. So you have to make its magnitude like the way you do in complex numbers. Tahirian cosmology, state of the art. So I have broken motion into two planes orthogonal to each other. One plane contains the string and the vector v prime, and the other plane contains the string and the vector v2 prime. Okay, both planes produce their own phase shifted force called Tahir force in history in the direction orthogonal to the plane. Both fall into each other's plane, counteracting other forces already in the plane. Amazing, isn't it? Guys, this is very important to understand. You have to watch my other videos as well, how I found out. I can't do everything in just one video. Summation of fx is equal to 0, mv prime square over r plus mv. Okay, now these two are not the component of the phase shifted force, guys. These are the components of, because I have broken the motion into two planes. So in both the planes, the ball is moving in circular orbit. So both are, now these are the components from the centrifugal force. And in both the directions of the ball, the d square r over dt square is equal to 0. So these are the not the components of the phase shift. These are the components of the centrifugal force. Because both are contributing. Plus mg cos theta is equal to t. After substitution, I obtained this. At theta is equal to pi by 2, we get t is equal to mg plus mr d square phi over dt square, because the other component d square theta over dt square become equal to 0. Why? Because theta become equal to pi by 2, d theta is equal to over dt is equal to 0, and d square theta is equal over dt square is also equal to 0. Now let me rewrite the previous equation as below. Okay, so I can write it this. We can substitute v square plus v2 prime square in it, and after some algebra we come at this equation. Tension is equal to mv square over r plus mg 1 minus v square over gr. So this is the, guys, okay. Now guys, this is the tension for the case 0 less than 90, theta less than 90 degree. Okay, so this is the tension. So the maximum tension occurs when the expression in the radical sign equal to 0. So this expression, guys, this expression, when it becomes equal to 0, we get the maximum tension for theta less than 0, less than pi by 2. Okay, so the solution of the above differential condition is, guys, a hyperbolic curve. Theta is equal to natural log of cos hyperbolic Vt over r plus r theta dot sub naught sine hyperbolic Vt over r with the following boundary conditions. When time is 0, theta is 0, and when time is 0, d theta of dt is equal to same rate of change. Okay, so T max is equal to, I can consider it with some initial angular velocity. You can put it into 0 and get theta is equal to ln cos hyperbolic Vt over r if you want. T max, okay, so this is the condition of Vt and theta. If Vt and theta follows this condition, then and move up, the ball moves up, then the tension will be maximum at a certain value of the angle, not at all values, at a certain value of the angle, or maybe at all values, I don't know, I haven't checked it yet, with the following boundary condition. T max is equal to mv square over r plus mg. So this is the max. So you can put, okay, so now you can put the values from v square over r from here, from this equation into this equation, and then you get this equation. So this is it, max tension, theta less than 0, less than pi by 2. The above equation is non-steady state equation of motion. When you have d theta over dt and d square theta equal to 0, then you get tension is equal to mg or mv square over r, because it becomes mv square over r. Like at theta is equal to 90 degree, the equation for steady state is as below. It becomes steady state. Okay. The above equation is non-steady state equation of motion. There is no clear indication of the angle at which T max will occur in non-steady state motion. But there is clear indication for steady state motion. Theta is equal to 45 degree gives the maximum tension in the string. At theta is equal to 90 degree, the equation for non-steady state is as below. You put the value, you get mg plus m r d square phi over dt square, because the d theta portion is, this is for steady, non-steady state, when the angular velocity in the other direction is not equal to 0 and its rate of change is also not equal to 0. So at theta is equal to 90 degree, the equation for steady state is as below. T is equal to mv square over r is equal to mg. When you check for balance in the vertical direction at theta is equal to 90 degree after phase shifting for non-steady state as before, for steady state phase shifting, we can likewise show that mv square is equal to mg plus mr d square phi over dt square. Why? Because the beta contains this expression automatically. So we get mg plus d square phi over dt square is equal to mv square over r. So the forces are balanced even in the non-steady state in the vertical direction after the phase shifting. The minimum tension occurs only for steady state at theta is equal to 0 and 90 degree. The minimum tension occurs only for steady state at theta is equal to 0 and 90 degree. And the minimum tension for the non-steady state I have already discussed above. However, if clear indication is given, it can also occur for non-steady state at theta is equal to 0 degree and 90 degree. Thanks for watching. And guys, please share this video so that my message can reach more people. Subhanallah walhamdulillah wala ilaha illallah wallahu akbar wala hawla wala quwwata illa billah al-aliyyil azim. Allahumma salli ala Muhammadin wa ala ali Muhammad kama sallaita ala Ibrahim wa ala ali Ibrahim innaka Hamidum Majid. Thanks for watching.